Welcome everyone. Hello and greetings of the day to everyone, the authors and invited guests. Welcome to technical session 8D. Myself Prashi and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 10th EDI International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of this conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the international event is being held through Zoom from 17th to 19th of July 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On the ninth minute, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box given down below. Just before we start our session, I would like to introduce you all to the chair of this session, Dr. Archana S. Bannett. Dr. Archana Satish Bannett is an assistant professor in the Department of Computer Engineering at Metz Institute of Engineering. She has 19 plus years of experience and has organized various workshops and seminars. She has also published 8 papers of international repute. We welcome you to the session, ma'am.
Thank you, ma'am. I am
Uh,
audible now?
yes, better now.
Yes.
Welcome to the session, ma'am.
Thank you, ma'am.
Now I would like to start our session by calling up our first presenter for this session. Our first presenter is Maushmi Milan Puri, presenting a paper on the title A Hybrid Deep Learning Approach for Cyberbullying Detection, Enhancing Performance and Interpretability with Attention Mechanism. I request you, if you are available with us, to kindly take over with your presentation, please.
Yes, ma'am, I am available. Should I start?
Yes, thank you.
Yeah, I'll just share my screen. Yes, yes, yeah, yeah. Sorry for the disturbance. Myself, Professor Maushmi Kuri, PhD research scholar under the supervision of Dr. Ganesh R. Pathak, sir. I am presenting my paper on a hybrid deep learning approach for cyberbullying detection, enhancing performance and interpretability with attention mechanism. I'll be covering the contents, motivation, literature review, research problem, proposed model, model comparison, conclusion, and references. The motivation. If you see, in the world, 28% of children around the world have experienced cyberbullying. And the highest rate of cyberbullying is in India and the US. In Asia Pacific region, India ranks the country facing highest cyberbullying. That's why cyberbullying is a growing concern. Nowadays, we see adolescents on their cell phones, computers, using their iPads for all such applications like Instagram, Facebook, and all. And it has been surveyed that 79% of cyberbullying incidences occur on the applications like Instagram, Facebook, and other apps like Twitter, YouTube, WhatsApp, and Snapchat. Most dangerous aspect of cyberbullying is that it often goes unnoticed because the parents are unaware that their adolescents are facing some kind of cyberbullying on social media sites. And in India, the environment is not so open that the kids will openly talk to their parents about cyberbullying. So this cyberbullying causes mental health issues in teenagers, and when faced, they have been shown also suicidal thoughts. And there is no much technical support or model existing which will detect and prevent cyberbullying. So we all know is cyberbullying is nothing but bullying over digital devices like cell phones, which can occur to SMS, text, and apps on social media. It includes sending, posting, or sharing negative and harmful content. also sharing personal and private informations which may result in unlawful or criminal behavior. This is the statistic, and if you see, India is 37% part of the cyberbullying status all over the world, and it stands at the first place. The reasons could be appearance, academic achievement, racism, sexuality, financial status, religion, and other. And as if we keep a survey of online platform, Instagram is the place where highest percentage of cyberbullying is happening, along with Facebook, Snapchat, WhatsApp, YouTube, and Twitter. There are different types of cyberbullyings. 20% could threat of personal harm. There could be personal attack, there could be sexual harassment, there could be trolling, doxing, and many things which we may not have imagined. And the effects are, as I said, suicidal thoughts. Some have even uh, done suicide. Kids may go in depression, they may have show a violent nature, or they may go towards alcohol. So it is very bad for your mental and physical health. Now, I had literature surveyed some of the papers where it was seen that most of the papers, there is no technology based intervention for this cyberbullying. Algorithms are required for big data, prediction models are required, deep learning techniques were not mostly tried. What was tried was NLP and ML algorithms. It needs a multi-class classification approach because it could happen through imaging, text, emojis. So the kind of data could be different. Feature selection should be done properly, and use of hybrid methods was recommended by many of the papers. So that is why I took this problem of cyberbullying as it was a growing concern, and traditional approaches to cyberbullying detection were ineffective. And machine learning models like SVM, Naive Bayes were showing promising results, but their performance lacked on images, videos, which forced me to use deep learning models. In the past, neural network based models outperformed NLPs, but deep learning based techniques gave a very good results for multi-modal data. Recent advancement in NLP has shown that RNN and CNN can give better result if they are combined and used on the algorithms. LSTM, which was used to classify text, w- could be used for feature extraction, and it gives very good results. Now, SVM, it is struggles with imbalanced data. Naive bias, it assumes feature independences. Decision trees are prone to overfitting. That's why deep learning methods like CNN, which was well in text but was unable to convey local dependencies. RNN, which is good for contextual dependencies but suffers from vanishing gradient issue. LSTM, it goes both, it is a memory state dependencies, but it is computationally expensive. By LSTM, it is context dependent, but it requires more training, and uh, transfer or image is for it captures the nuances in the language. Sometimes we sarcastically say some words which mean something. So transformers can be used to capture the nuances, but it requires a large data set. So the proposed model was combining all these features and using their best feature to give the best result. So first the pre-processing was done, in which tokenization, lemmatization, and stop words were removed. Then the text was converted into vectors by using GRE with glow embeddings. Feature extraction was done using CNN. Sequential and contextual dependencies were checked using by LSTM, which goes in both the direction. Contextual embeddings were checked using the transformer based models, which were BERT and Roberta, and the interpretability was being checked by using attention mechanism. Now, this was the model accuracy. Training accuracy showed a 0.95, 96%, and validation accuracy was 0.83 around. The model comparison, if we compare this model with the previous model, this has enhanced feature extraction, improved context understanding, better generalization, robustness against evasive strategies, scalability, and efficiency. Now, enhanced feature extraction was done by combining BERT, Roberta, CNN, and GRU. Improved context understanding nuisances were through transformer based architecture. Better generalization was using hybrid modules, which reduces overfitting. Robustness against evasive strategies captures both spatial and temporal um, dependencies. And scalability was because hybrid model can be optimized for its accuracy and efficiency.
Excuse me, ma'am. I'm really sorry
Yeah.
to interrupt you. However, we have crossed the 10-minute mark. So I
Okay,
request.
one last slide. Enhancing the interpretability was with attention mechanism, which concentrates on the most pertinent portions of text. Self attention also assesses the relative relevance of words. Bahadano helps model to focus on important words during prediction, and long attention improves the model's ability to capture dependencies in abusive conversation. So my conclusion is like using hybrid deep learning framework has demonstrated strong performance, and by integrating deep learning and adding attention mechanism has improved the transparencies. So these are my references. Thank you.
Thank you so much, ma'am. Dr.
Yeah.
Archana, ma'am, do we have any questions for ma'am? Ma'am, we are unable to hear you. Okay. There might be some technical glitch, ma'am. No issues. Uh, Ma'am, could you write it to me in the chat box if any questions are there? Okay. No issues. There might be. Okay. Ma'am has written what are the methods you used to improve their context.
Contextual.
Yes, ma'am. What were the methods you
C-
used?
CNN, CNN and by LSTM were used to find the contextual dependencies.
Okay. Thank you so much for your presentation, ma'am. Now we will move on to our next presenter.
Thank you. Thank you very much, ma'am.
Thank you. Our next presenter is Devi VS, presenting a paper on the title Assessing the Effectiveness of Deductions and Exemptions in Income Tax for Promoting Savings and Investments. I request you, if you are available with us right now, to kindly take over with your presentation, please.
Yes, ma'am. So am I audible?
Yes, ma'am, you're audible.
Okay. So let me share my PPT. So is my screen visible?
Now it is visible, ma'am.
Okay. So let me start with the presentation. So good afternoon, everyone. I'm Devi VS, and I'm currently pursuing my PhD at the Department of Commerce and Management at Amrita Vishwavidyapeetham, Amritapuri, India. Today, I will be presenting a study that evaluates how effective income tax deductions and exemptions are in promoting savings and investment in India. So today, I will be covering these areas like introduction, review of literature, objectives of the study, research methodology, data analysis and interpretation, findings, suggestion and conclusion, and then finally the references. So, introduction. So the government has introduced various tax incentives, mainly under Section 80C and 80D, to encourage individuals to think long term when it comes to their finances. This research looks at how these incentives actually influence taxpayer behavior and savings trends. It identifies financial instruments like provident funds, national savings certificates, and insurance products as being most impacted by these benefits. However, the study also finds that despite their positive impact, the full potential of these tax measures is not being realized largely due to low financial literacy and limited public awareness. In closing, the paper offers the practical recommendations to improve policy communication and accessibility while also aligning tax benefits with broader economic goals to build a more savings conscious society. So, followed by the review of literature. So, the literature shows that tax incentives can effectively increase disposable income, encouraging
Excuse me, ma'am.
individuals to.
Could you please show the full screen presentation? Basically, can you do F5 for slideshow?
Yeah, can you see that?
We can see it. However, can you do you press F5 for slideshow presentation so that is visible on the whole screen.
Okay, now is it visible?
Your screen is. However, our session chair is asking if you could present it on a full screen. Basically, can you click F5 if possible?
Uh,
Go to slideshow option. The option which you see on top tab. Go to slideshow and do slideshow.
1 minute. Huh?
It is next to
I think
animations.
I think there is some technical issues.
Okay, you are presenting you're doing a slideshow. You can just.
Actually,
Yes.
I don't know, but I couldn't see anything. I think there is some technical issue.
No
So
issues, ma'am. I request you to kindly continue with this. No issues.
actually,
Yes.
actually, I am stuck with this presentation. I am unable to do anything with the slide.
Understood. You please continue, ma'am.
Okay. So, however, a study conducted by Bhandari and Reddy in 2020 argues that many individuals treat these provisions as short-term tax relief, not as tools for long-term investment. A recurring theme in literature from Potterba in 1997, Saha and Chakrabarti in 2019 is the disproportionate benefit to higher income individuals. And additional challenges include complexity of tax systems and low financial literacy, as noted by Agarwal in 2018. And Taylor and Sunstein in 2008 add that behavioral factors like present bias also limit long term savings behavior. Then, moving on to the objective of my study. Actually, I am stuck with this presentation, so I'm unable to move the next slide. Is it okay?
Can you just reshare your screen once?
Um,
Just stop sharing and then just again you share the screen.
1 minute.
Just once you do reshare that, it will give you a clear picture of the exact screen you are sharing to us.
Okay, is it visible?
We can see the review of literature screen right now, ma'am. So if that is the one you're sharing, we can view it.
Okay. So this is the objective of the study. Are you able to see?
Yes, yes, we can see. Please continue.
Okay. So the main objective of my study is to assess how effectively income tax deductions and exemptions, particularly under Section 80C and 80D of the Income Tax Act, encourage savings and investments among individuals in India. So moving on to the research methodology. In this study, I adopted a quantitative approach used to assess effectiveness of tax. Hello, are you able to hear me?
Yes, ma'am, we can hear you clearly.
Okay. In this study, I adopted a quantitative survey approach, and the data was collected using a structured survey questionnaire distributed among a sample of 500 individual taxpayers. So, to group the respondents based on demographic variables, I used stratified random sampling method to ensure that the age, income levels, and regions were also included. So the survey explored respondents' knowledge and use of popular tax saving sections such as ATC, which includes instruments like Public Provident Fund, National Savings Certificate, life insurance premiums, and equity linked savings scheme, and ATD relating to health insurance premiums. In addition to that, demographic details were also collected to examine how these factors influence awareness and utilization of tax benefits. The data was analyzed using SPSS software by applying both descriptive and inferential statistics, including regression analysis, to uncover how awareness and demographics impact savings and investment decisions. So I'm moving on to the next slide, the data analysis and interpretation part. So the data analysis and interpretation part, I have used descriptive statistics to examine key variables. And for that, for 500 participants, as you can see, the average investment amount was rupees 35,000 with a standard deviation of rupees 5,000, and tax deduction claimed average rupees 25,000 with a standard deviation of 6,000. These figures show moderate variability and indicate active engagement with tax saving instruments like Public Provident Fund, National Savings Certificate, and life insurance, as shown in the next slide. To explore differences across income levels, ANOVA test was conducted. The results were statistically significant, as you can see that the F value is 15.6 and P value of 0.001, meaning the differences in investment amounts and tax deductions among income groups are unlikely to have occurred by chance. It is observed that higher income individuals tend to invest more and claim higher tax deductions, likely due to greater disposable income. On the other hand, lower income individuals may not be utilizing these provisions to their full extent, possibly due to resource constraints or lack of awareness. To support this, correlation and regression analysis were also conducted, which showed a positive relationship between tax provision usage and savings behavior, even after controlling for income and age. So next, I am presenting my final slide, findings, suggestion, and conclusion. So these are the findings of my study. The data clearly shows that the tax incentives positively impact overall savings behavior. Higher income individuals invest more and claim larger deductions, while lower income groups participate less, not due to because lack of access, but due to limited disposable income. This was confirmed through an ANOVA analysis, which showed statistical significant income-based disparities, as I have shown in the previous slide. Then followed by my suggestion. Firstly, expanding tax deductions to include small value investments such as recurring deposits and small savings schemes can help lower income individuals participate more effectively. These instruments are widely accessible but often excluded from tax benefits. Secondly, I recommend implementing auto enrollment into tax saving schemes like the National Pension System and Suganya Samriddhi Yojana for beneficiaries of government welfare programs. This automatic inclusion will help overcome barriers like lack of awareness, ensuring wider participation. Finally, integrating tax saving schemes with direct government co-investments could be a powerful incentive. For instance, savings made in eligible instruments such as post office deposits or the national pension system should qualify for both tax deductions and government matching contributions. This dual approach would particularly benefit lower income groups by increasing their effective savings. And followed by the conclusion, the study finds that while income tax deductions do encourage savings and investments, overall these benefits are disproportionately captured by higher income groups who have more disposable income. Lower income individuals face challenges such as limited resources and lower financial literacy, which hinder their ability to utilize these incentives fully. This highlights a critical gap in policy accessibility and inclusiveness. To address this, the government should focus on reforms that make tax and saving instruments more flexible and accessible and invest in financial literacy programs targeting lower income groups. Furthermore, tax policy should not only promote short term tax savings but also encourage long term financial security, including retirement savings and wealth creation. The shift in focus will support sustainable economic well being across all income levels. Finally, future research is essential to evaluate the long term effects of tax reforms on wealth accumulation and retirement planning, especially for vulnerable populations. In summary, while tax deductions and exemptions are valuable tools, a more inclusive, comprehensive policy framework is necessary to ensure these incentives promote savings and financial security for all. And that's all with my presentation. Thank you.
Thank you so much, ma'am, for your presentation. We have a query from Dr. Archana. How
Yeah.
many cases you studied for implementation of this?
Sorry, could you repeat that question?
Ma'am has written that question in the chat box also. How many used cases you studied for implementation?
I have collected data from 500 respondents.
Okay. Ma'am, are there any further questions for ma'am? Whether it includes all schemes of government?
Actually, it is 80C and 80D. I'm focusing on 80C and 80D. Actually, my topic is that.
Okay.
That is assessing the effectiveness of deductions and exemptions in income tax for promoting savings and investments. So section 80C and 80D are mainly focusing on that. So I only focused on section 80C and 80D.
Okay. Thank you so much for the explanation and the presentation, ma'am. Now we'll
Thank you.
call upon our next presenter for this session.
അതവർക്ക് സ്ക്രീൻ കാണാൻ ഒക്കുന്നുണ്ടായിരുന്നില്ല. ശരി, ചെയ്തു കഴിഞ്ഞു ഇതൊന്നും നന്നായിട്ടുണ്ട്.
Our next presenter is Akash Tibili, Design Verification, and he's presenting a paper on the title Design and Verification of AHP to ABP Bridge. I request you to kindly take over with the presentation, please.
Hello, Prashi. Am I audible?
Yes, sir, you're audible.
Yeah. So kindly tell me, are you able to see my screen?
Yes, sir, we can see your screen.
Is the slideshow turned on?
Yes, sir, the slideshow is on.
Okay, thank you. Good afternoon and all. Myself Akash Tibeli. So I am a student I'm postgraduate student at KLA Technological University, Hubli. So I will take you through my paper, Design and Verification of AHB to APB Bridge. So the content are as follows, followed by introduction, literature survey, objectives, methodology, results, etc. So before going on to the AHB to APB bridge, let us understand what is an AHB and APB. So an AHB is an high-speed pipeline and bus-supported bus, primarily used for high bandwidth communication. In contrast, APB is designed for low power peripherals that do not require high-speed communication. Let me give an example. So we need to have, if an ARM processor wants to communicate with an UART, so it can't directly communicate with UART. So what it does is ARM processor will dump its signals on an AHB bus, and AHB bus will in turn communicate with APB bus, and APB bus will dump those signals back to the UART. Now, the problem is an AHP bus is an pipeline protocol, but APP bus is a non-pipeline protocol. So, to make that protocol integrity viable, we need to design a bridge which can take care of both the AHP protocol and APP protocol. So I have gone through some papers, around 4 to 5 papers, on how people have designed this particular bridge, and I also done the verification of that bridge. So I can just skip this data survey and go on to the design and verification methodology. So coming on to the objectives. So initially, I have designed an AHB to APB bridge using Verilog HDL language, and then I have verified that particular bridge using an UVM technology, which is built on top of a system Verilog verification methodology, and also validating the protocol integrity using system Verilog assertion and enhancement of functional and code coverage of the designed bridge. So coming on to the design methodology. So an AMBA bridge, which is an AHB to APB bridge, is an AHB slave, interfacing a communication between high perform AHB and low peripheral APB. So here what it does is write and read transactions on the AHB are transformed into similar smaller transactions on the APB. So in the figure, we can see that actually, it works on 5 methods or 5 steps. First one is AHP transaction initiation. So as I earlier explained about an example of ARM, so ARM will dump its signals into an AHB master. So AHB master will initiate the transaction by driving valid signals like HWrite, HW data, HTrans, and HAddress. These are all the signals to the AHB slave. The AHB slave interface receives these respective signals and determines whether it is a read operation or a write operation. And the second step is transaction decoding and FSM control. So the FSM bridge decodes the transaction type and address from the AHB. It passes through the states to manage the data process. So I will explain you the transaction states in the next slide. Now the third step, which is an ABB signal generation. FSM generates signals like address, so write, read with respect to the APB. So based on the AHB signals. So now how the APB execution is done. APB peripherals responds to the signals like p-select, p-address, and other signals to perform required read or write operation. So at last, coming to acknowledgement, FSM ensures that the transaction completes successfully. It deasserts control signals and updates the H ready out signal, which is an acknowledgement signal, H ready out. So next, coming on to the FSM. So here, the signals will travel through this FSM, which will be having around 6 states. So first state, which is an ideal state. So there will be no transaction occurring in this state as the valid signal is low and respective p-select and p-enable signals will be driven low. Now from the ideal state, it goes to the state read. When the valid signal goes high and H-write signal goes low, the AHB address is deciphered on and driven on the P address, which is on the APB side, activating the respective slave signal and inserting P-write as low. Earlier, I have said that AHB is a pipeline protocol and APB is a non-pipeline protocol. So I will be initiating a wait state from state ideal to state W wait. Here, what happens is the wait state is inserted to halt the respective AHB write signals so that APB can receive the signal based on its clock frequency. And from the state wait, it goes to the state write P, which is on the APB side. When the valid and H write signal goes low, the APB here also the APB address is deciphered. Here for it is deciphered for APB write transaction, and in the state read, it is deciphered for APB read transaction. From the state read, it will go on to the next state, which is state read enable. Here, the P enabled signal is driven high, which enables the APB transfer, which is APB read. And coming to the state write enable, here also the P enable signal is made high. Here it enables the APB's write transfer. And at last, I am having another wait state. This is an extra wait state inserted to allow the write transaction to complete, which is followed by a read transfer. So this is all about the design methodology. To test this particular design, so according to the industry standard norms, we have to test the design either using a system verilog verification or an UVM test bench. So I have chosen an UVM test bench because it facilitates reusability, it is scalable, and it is efficient for functional coverage verification process. And on top of that, it is built on system verilog and provides a structured approach to verification using OOPS concepts. Let me explain you how the verification flow is. Initially, we have a top module. In the top module, we have another sub two modules, which is a test module and a DUT. DUT stands for design under test, which is a proposed design. So the proposed design will be connected with the test module. Here, we will be having interfaces. So what is the need of an interface? Since we are using OOPS concepts inside the environment, it is dynamic in nature, but our design is static in nature. So to make a synchronization communication between the environment and the DUT, we will be having interfaces. Interface is just a bundle of signals which will be having clocking blocks so that those signals can be used anywhere in driver, monitor, or scoreboard, etc. So let us understand the data flow. Okay, initially I will be generating a different sequences. Sequences stands for different input combinations, which I want to test which I want to send as an input to the design under test. Initially, these sequences will be sent to the driver through a sequencer. And coming before that, we will be having agents. Agent is simply a top module which will be considering sequencer, driver, and monitor, and it also does the connection between the sequencer and the driver. Coming back, AHB sequencers will be driven to the driver. So these input combinations, and driver will drive these input combinations to the DUT through an AHB interface. Now the design will calculate the output, and the result will be given back to monitor through an AHB interface. Now, monitor will transfer the output signals to the scoreboard. Now, coming on to the scoreboard, scoreboard is the heart of a verification test bench. So, scoreboard has majorly two modules. One is a reference model, another one is coverage. Coming on to the reference model, so there will be two teams, like there will be a verification team and there will be a design team, RTL design team. So, RTL design team will design the AHB to APB bridge, and verification team will write a reference model with their own understanding of the specifications. And now both the outputs of both the reference model and the DUT will be compared inside the scoreboard. And if the comparison is true, then the particular test case I wanted to test is done. Now coming on to the coverage, there are two types of coverages. One is a functional coverage, another one is code coverage. Functional coverage is written by a verification team, which will validate the integrity of the input values. And the code coverage is simply the coverage of the entire design, like how much of an FSM is covered, how much of branches are covered in the code, how much of an modules are covered, like that. So this is how test bench environment works. Coming on to the test cases, I have written around 80 test cases for this particular design. The test cases will I have written the sequential transfer, non-sequential transfer, ideal transfer, wrap forward burst, incremental forward burst. It can be a half word, a full word. So like this, I have written around 80 test cases to test the design. So coming on to the results, initially I have just checked initially I have just written a simple test bench to check the functionality of the design. Here in the test bench, you can see in the waveform, you can see that this particular HW data, I am providing a
Sorry to
data.
interrupt you, sir. We have crossed the 10-minute mark. I request you to kindly conclude as soon as possible, please.
Okay, I'll just take another 1 minute. Okay, so the HW data here, I'm providing 163, and that same data I'll be getting it in the AHB side. So this is the waveform for the complete regression. So I told you, right, I have written around 80 test cases. So this is the waveform for the all the test cases combined. And coming on to the coverage. So here we can see that I have attained around 88.8% coverage, which includes the write, read, and different types of signals like sequential, non-sequential, other H trans bursts like that. So I have cover. It's a total coverage is around 88%. So coming on to the conclusion, so the bridge was successfully designed, verified, and optimized to attain functional correctness of 88% and efficient performance with QuestaSim tool. And at last, the EDA tool which I have used is QuestaSim. So these are the references. Thank you.
Thank you so much, sir. Dr. Archana ma'am, do we have any questions for sir? Ma'am has written her question in the chat box, so I request you to kindly have a look at the question. What are the benefits of this technique over existing? Is there any
Uh,
significant change in performance?
like if I mean if she is trying to ask about verification techniques or what.
Verification techniques, yes.
Yeah, okay. So initially, industry was used to verify the design using system Verilog test bench, which is a very rigorous kind of things. There we can't have the constrained random verification. We need to write direct test cases. But here in the UVM test bench, I can drive the stimulus randomly, and it can attain a good number, I mean, a good number of functional coverage as compared to the SV test bench.
Is it all, ma'am? Do we have any other question? Okay. Thank you so much, sir, for your presentation.
Thank you, Pashi.
Ma'am is satisfied with that. Thank you. So next presenter I would like to call upon is Judy K. George, presenting a paper on the title Fixation, Guided Recognition and Characterization of Handwritten Characters. I request you, if you are available with us right now, to kindly take over with your presentation, please.
Okay, thank you. Am I audible?
Yes, you are.
Okay, I will share my screen. Is it visible now?
Now your screen is visible. However,
But a
yeah, we can see the
presentation.
presentation.
Okay, fine. So myself, Judy K. George, going to present my topic fixation guided recognition and categorization of handwritten characters. I'm a research scholar from Digital University, Kerala. My presentation includes introduction, motivation, related works, researcher gap, methodology, results and analysis, conclusion and future work references. So around 10 raised to 8 to 10 raised to 9 beats per second of information is entering our eyes per second. But our brain is not able to process all these information at once. So our human visual system fixates on task relevant regions. The human visual system is highly efficient at processing complex scenes by selectively focusing on the most task relevant regions. This process is known as visual fixation. That is, instead of analyzing the entire visual field in detail, our eyes make rapid movements called saccades and pause briefly at some locations known as fixations to extract the key information necessary for tasks like reading or recognizing objects. From the image shown, this is an image taken from the Silicon dataset which uses eye tracker for the data for collecting data. From a saliency map is shown side by side, which gives us the fixation points. That the humans, when humans see this image, they will be concentrating more on these particular points. So this is fixation. Inspired by these biological attention mechanisms, there should be, a model is proposed for the handwritten character recognition. So the aim of my model is to learn, recognize, explain, and reconstruct the handwritten characters. The datasets which I used are Malayalam, English, and MNIST dataset. Coming to the related works, early approaches predominantly relied on the rule-based algorithms for feature extractions. After the introduction of CNN, the LANET, which was by Lacan, they extract the spatial features directly from pixels, which is used for the character classification. Later models like BGG, which increased the more where number of layers are more, it is also used for the character recognition. Then ResNet were introduced later. CNNs combined with RNNs, LSTMs to identify the characters and do the recognition. Anyway, all these models across these many models, CNN, RNN, and other models often perform well in classification tasks. They don't clearly explain how or why they reach this particular decision. So my research gap is lack of interpretability in CNN based HCR models, that is handwritten character recognition models, limited use of attention mechanism, no integration of saliency with reconstruction, neglect of complex scripts in attention research, which means that the existing deep learning models act as black boxes. While they achieve higher accuracy, they do not provide insights into which parts of the image influence their predictions. Also, the attention models which have been used in computer vision tasks, their application in the handwritten character recognition is limited, especially for the complex scripts like Malayalam. Also, previous models either focused on classification or attention visualization. Very few attempt to reconstruct image based on the attention. So there is a gap in developing multitask models that combine classification, human-like attention, visual explanation, and reconstruction. Also, the most models are trained on the standard data sets like MNIST. The complex and diverse scripts like Malayalam is not considered. So this was the proposed architecture. It includes an encoder part with a GradCam module, then a decoder part, and a classification part. So coming to the encoder part, I have used a pre-trained ResNet 18 as an encoder for the high-level feature extraction. In the encoder part, the fully connected classification head part is removed, and it extracts the intermediate feature maps also for the decoder part. Then a fixation point generator, that is it is a lightweight attention mechanisms. It takes the 512 dimensional global average pooled vector from the deepest encoder layer and then use a two layer MLP to generate a 28 cross 28 map. Then coming to the GradCam part, it integrated with the forward and backward hooks on the final encoder layer, which captures the gradients during back propagation to compute the channel-wise importance. So then they said unit decoder is there. It utilizes the skip connections to concatenate the encoder features at the corresponding resolutions. Also, the final layer is a sigmoid activated convolution layer that reconstructed the 3D three channel image. So there is a classification part also which process the reconstructed images, and it consists of the convolution layers, pooling layer, as well as the connected layers. So to coming to the loss function, to train the model that both classify handwritten characters accurately and reconstruct the original input meaningfully, it is trained using a total loss that combines classification from accuracy and the reconstruction quality. For the classification part, I have used the cross entropy loss, and for the reconstruction loss, mean square error is used. The alpha parameter allows us to control how much we want the model to focus on reconstructing the input alongside predicting the correct class. This encourages the network to preserve class relevant features during reconstruction, supporting interpretability. This is the training and test. Training loss as well as the training and validation accuracy. For the MNIST dataset, it has got a training accuracy of 99.56. For the English dataset, it has got 97.85, and Malayalam handwritten dataset, it has got 99.21. Coming to the comparative overview of F1 score, I have considered the three dataset Malayalam, English, and MNIST. Coming to the script type, the Malayalam is more complex than English and MNIST. For the Malayalam, I have considered 48 classes, English 26, and for MNIST it is 10. The minimum F1 score I have obtained for Malayalam is 0.830 and the maximum F1 score is 1. And the F1 score variability is moderate in case of Malayalam, but the class confusability is high compared to the other dataset. Overall, the model fit was robust in case of Malayalam, consistent in case of English, and near perfect in case of MNIST. So, here I show the Grand Cam visualization of English letter H. This one is from the GradCam map of second layer. This second encoder 2 and this is encoder 3 and this is the encoder 4. So when the particular system, this is model is seeing a letter like H, it will be concentrating on these all positions to make a decision. So coming to the MNIST data set, I have considered the 7. So in each layers, it is considering these all portions for the reconstruction as well as classification. This is Malayalam letter Cha has used these parts for the reconstruction. In this case, in this slide, I have represented representing the variations of digit 4. The digit is stylized with a slanted form. Here, the digit is stylized with a standard slanted form, and here the digit is in the standard form. In both the cases, the central intersection and the bars around that intersection is concentrating more for the prediction. And after that, I have showed the reconstructed image. Similarly, in the case of English letter H, these two parts, the central horizontal stroke and the side limbs, these two things are contributing more for the predictions. This is with the Malayalam letters. It includes the vowels and consonants of Malayalam handwritten data sets. So each part, these circles and these lines, the curves, contours are constant are contributing for the letter prediction. So coming to the conclusion and future work, in this work, I have introduced a multitask deep learning framework that unifies handwritten character classification, image reconstruction, visual explanation via saliency maps. I have used a ResNet-based unit architecture enhanced with fixation point generator and GradCam, and I have achieved an accuracy of 100% in case of MNIST, 92.81 in case of English, and 98.44 in case of Malayalam. I have demonstrated the model interpretability with detailed saliency visualization that boosts both performance and trustworthiness. Future work includes handling more complex writing tasks by including human data also, human fixation points. Designing AI systems that mimic the human like attention aligns with the sustainable development goals by saving energy as well as sustainable hardware use and low energy demand. It will support transparency, encourage eco-conscious AI designs. And that's all my presentation. These are my references, and thank you.
Thank you so much for your presentation, ma'am. We have a question from our chair. What is the accuracy obtained in the base paper, and did you use any deep learning algorithm in hybrid model? You can see her question in the chat box as well. Mode. Okay. If you want me to repeat the question, I can do that. What is the accuracy obtained in base paper, and did you use any deep learning algorithm in hybrid mode? Ma'am Judy?
Hello, can you
Yes,
hear me?
yes.
When you see the handwritten classification papers, you can see most of the models have achieved above 95 percentage accuracy. But in case of MNIST have achieved 99 percentage accuracy in most of the papers. But coming to the Malayalam classification, the accuracy will be above 85 percentage. But in my paper, I have not only considered the classification, uh, I have considered the reconstruction of the particular characters, taking only the relevant features from the handwritten character and reconstruct that particular character. And based on that reconstructed character, I have done the classification. Okay. Is that okay?
Thank you so much for your answer. Moving on to our next presenter. Okay, we have one more question. More suitable for Malayalam as there is no difference in accuracy. Okay,
Yes, ma'am. Yes, ma'am.
so now I'll move on to our next presenter for this session. Thank you so much. Next presenter is Prathamesh Vilas Sagwekar, presenting a paper on the title Fraud Lens, a Deep Fake Intelligence with ML. I request you to kindly take over with your presentation, please.
Is my screen visible, ma'am?
I'll just check on the computer.
Is my screen
Yes,
visible?
yes, it is visible, sir.
Is it now full screen?
Yes, it is on full screen now.
Okay. So, good afternoon, respected session chair and fellow researcher. I am Prathamesh Sagwekar, and today, along with my co-authors, I will be presenting our paper titled Fraud Lens, Deepfake Intelligence with Machine Learning, submitted under paper ID 878. We are from Shahanekar Kachi Engineering College, Mumbai. Let's begin. Introduction. Deepfake technology has rapidly evolved and poses a significant threat in domains like fraud, misinformation, and identity theft. Our paper presents a practical and systematic guide to deepfake detection using machine learning. We review state of art models and also discuss data preprocessing, implementation pipeline, and challenges faced. The goal is to bridge theory and practice for creating real world adaptive detection systems, accessible even for students and early stage professionals. Research overview. Deepfakes are AI generated manipulations of video or audio clips. Initially designed for entertainment, they are now being used for misuse to create fraudulent content. This increasing misuse has raised the need of robust detection techniques. Our research provides an end-to-end roadmap for detection. Background and evolution. Around 2014, deepfake began early face swapping used graphic-based non-AI techniques. By 2016, GANs revolutionized the space, enabling higher quality fake content. In 2018, platforms like FaceApp, FakeApp made deepfake generation publicly accessible, increasing risks. By 2020, real-time face and voice manipulation often used for misinformation or fraud. By 2021, multimodal deepfakes like text-to-image, DALL-E, full body motion transfer models, real-time deepfake manipulations are being done. Most recently, from 2023 onwards, we have seen AI-generated full body, voice, and motion forgeries using cryptographic watermarking. Data collection and preprocessing. Effective deepfake data detection starts from high quality data. Commonly used datasets include Face Forensics++, CelebDF, and DFDC. The pre-processing pipeline typically involves extracting frames from videos, resizing and normalization to fit model input formats, augmentation techniques such as flipping or brightness variation to improve generalization. This step helps maintain consistency and improve performance of detection models. Model training. Several models have been processed in literature for defect detection, in which exception rate known as high accuracy and detecting spatial anomalies. Mesonet valued for high lightweight architecture and real-time capabilities. Additionally, custom CNNs are often built to focus on specific facial regions or manipulative patterns. These models are generally trained using supervised learning on pre-processed frame-level data to learn distinguishing features of real versus fake media. Workflow. This diagram outlines a typical workflow in defect detection systems. Input is received in the form of video or image. It undergoes the validation for format and size. Frames are extracted from video for feature analysis. Pre-processing ensures all data is uniformly scaled or normalized. The data is then batched and passed to detection model. The output is classified whether the input is real or fake. Such modular workflow supports adaptability across different input formats and models. Conclusion and future work. Looking ahead, future direction in field includes real-time defect detection during the live video calls, improving robustness against adversarial manipulations, integration into web browser and social platforms through plugins, development of easy-to-use application for public access. These efforts aim to make defect detection scalable and accessible. In summary, defect detection research integrates several elements from data collection and model selection to pipeline design. Thank you for the attention. Now, we now open for feedback.
Okay, thank you so much for your presentation. Ma'am, do we have any questions? Okay. Can you explain exceptionate?
Uh, Exception rate is basically used for high level model training, in which it's a pre-trained model which has high accuracy in detecting spatial anomalies. Whereas Mesonet is also a lightweight competitor of it for real-time use.
Is it
Any more
specific for
questions?
any environment? Ma'am is writing it in the chat. You can see the chat as well. Is it specific for any anomaly?
Uh, Actually, my co-author is responding for this question.
Okay. Is he speak?
Uh, was it audible, ma'am?
No, sir, that was not audible. That is why we are asking. Okay, it is audible. It was audible for ma'am. Okay.
Okay. So can I conclude?
Yes, you can continue, sir.
Thank you.
Now I'll call upon our next participant. Our next participant is Pranay Samal, presenting a paper on the title Graph Neural Networks for Music Recommendation. I request you to kindly take over with your presentation, please.
Yes, hi, I'm Pranay Sharma.
Okay.
Am I audible?
Yes, they are.
Yeah, just a minute. Yes, yes. Hi, good morning, good afternoon. I'm Pranesh Amal. Today I will be presenting our work title on graph neural networks for music recommendation, done in collaboration with my co-authors from Pune Lakshmi Education Foundation, Hyderabad. Yeah. Introduction. The music recommendation system, which helps user find songs that match
Sorry to
their
interrupt you,
preferences.
sir. Can you make the presentation full screen by any chance?
Yeah, it is full screen for myself.
Okay.
Yeah, is it visible in full screen?
It is not, but I think you can continue with this. Can see the presentation.
Okay.
Okay.
Yeah. In music recommendation system, it helps users find songs that match their preferences. But the traditional methods like collaborative filtering and content-based filtering struggles with cold start problems and sparse data. Our aim is to build a more personalized recommendation system using graph neural networks, which can model complex user-artist relationship more efficiently. Uh, the previous works are like area system. Earlier systems relied on collaborative filtering and content-based filtering. Deep learning models like CNNs and RNNs are later used to capture user features and song characteristics. Recently, graph-based models like GNN have shown promise in modeling relationships in heterogeneous data structures. Our work builds on that by comparing models like GCN, GAE, HGD, and MACGNN. We use dataset as a last system. It has which includes 1,892 users, over 17,000 artists. Each user artist interaction is treated as an edge in a graph. Like tags like rock or jazz are used as metadata, and time steps were help capture the temporal listening behavior. Uh, Our proposed model, we experienced with four models, MACGNN, GCN, GAE, and HGT. MACGNN uses metapath-based attention in heterogeneous graphics. GCN, which uses convolution on neighboring nodes. GAE uses embeddings and reconstructs the graph. And HGT, which uses type-specific attention across different node types. Our goal was to compare these and identify the best performance model. Our proposed start with our methodology. Our proposed start with data pre-processing and exploratory data analysis, transforming raw user artist interactions into a heterogeneous graph. We trained all four models using optimized parameters and evaluated their performance using metrics like accuracies, ROC, AUC, and MAP to understand which model best captures user preferences. Uh, this Yeah. Uh, the MacGNN achieved a 73% training accuracy and 85% test accuracy, indicates a strong generalization. GCN and GAE are only achieved 43 and 50% respectively. This shows that a MacGN is specifically better at capturing complex semantic relationships in user behavior. Uh, Our discussion highlights that MacGNN maintains a good balance between training and testing accuracy, avoiding overfitting. Its attention-based aggregation allows it to learn from rich user artist tag paths, making it ideal for personalized music recommendation.
Excuse me, sir. Could you please reshare your screen once? One second. I can only see the introduction right now. Just a second. Could you please
Yeah.
reshare your screen once?
Okay. Okay. Yeah. Is it visible?
Yes, correct. Thank you.
Yeah. Yeah, I'll continue with the results and discussion. Here is the result comparison between MaxGN and other models. MaxGN achieved 73% training accuracy and 85% test accuracy, indicating a strong generalization. GCN and GA are only achieved 43% and 50% respectively. This shows that MaxGN is significantly better at capturing complex semantic relationships in user behavior. Our discussion highlights that MaxGNN maintains a good balance between training and testing accuracy, avoiding overfitting and all. Its attention-based aggregation allows it to learn from richer user artist tag paths, making it ideal for personalized music recommendation system. To conclude, our study demonstrated that graphical neural networks, especially MaxGNN, significantly improves music recommendation quality by learning from heterogeneous user artist interactions. The last FM dataset provide a strong base with rich metadata. The future work can conclude real-time data integration and hybrid models for even better personalization. Thank you for your attention.
Thank you so much, sir. Ma'am, do we have any questions for him? So, ma'am's question is, what is the uniqueness in Maven?
Yes, the MaxGNN has very much unique than other GNN models. Uh, it combines metapath guided message passing between attention-based aggregation and enable its model complex heterogeneous graphs far better than standard GNNs.
Ma'am, do we have any other question? All right. Thank you so much for your explanation and your presentation, sir. Now, moving on, I would like to call upon our next presenter for this session. Our next presenter for this session is Akash Mekwan, presenting a paper on the title Incorporating a Crypto Processor on Risk-Free Architecture. I request you to kindly take over with the presentation, please.
Hello, am I audible?
Yes, sir.
Hello?
Yes, sir, you're audible to us.
Yeah, I'll just start.
Okay.
I'll share the screen and start.
Yes.
Is the screen visible now?
Yes, sir, your screen is visible.
Okay, so I'll start.
Okay.
So good afternoon, everyone. This is Dr. Akash Mekwan from Nirma University, Ahmedabad. And I'm going to present on incorporating crypto processors on RISC processor architecture. Basically, this is a work done by one of my UG student, Miss Arya Tripathi. She is not here to present, so I am going to present on her behalf. So this is the outline. I'll first present the motivation why we have chosen this particular topic, then the overview of the project, then the encryption algorithm, core of RISC-V, the interconnect between the crypto processor and main processor, then the integration, and finally conclusion and results. So the basic motivation is that the RISC-V is a very popular architecture, which is open source and flexible. We can modify or customize the same as per our choice. So that is our first choice, the RISC processor. But there is no security aspects available in the RISC processor. So we thought that we can design a cryptographic algorithm on RISC-V processor. But if we design a cryptographic processor on RISC-V processor itself, then it will take a lot of resources. And the RISC-V processor may not work with the full efficiency. So we have thought that we will go with the coprocessor. That coprocessor will help the RISC-V processor in providing the encryption description. At the same time, it will not use the full resources of RISC-V processor. So our main motivation is to design a crypto processor. that can handle the encryption and decryption, and it can be attached to RISC-V processor using any interface. That was the basic motivation. These are the three main objectives. The first objective is to integrate a dedicated crypto processor with using Blowfish algorithm to create custom instruction in RISC-V. So when we require encryption and decryption, or when we want to use this coprocessor, we can directly use with the custom instruction. And the other objective is to use AXI light interface to establish the communication between the crypto processor and the main processor. So the overview is like this. We have a RISC-V core and a Blowfish cryptographic module algorithm, and we have connected them using AXI light interface, which works on 64-bit data. So this is what we want to develop. RISC-V processor, the already available core that we have used. Blowfish module we have developed in Verilog, and AXI interface also we have directly taken, which is available open, and then we have interfaced it. So first I'll discuss the Blowfish encryption module. The Blowfish encryption module is like this. In encryption module, there are different iteration process. This iteration number 1, iteration number 15, iteration number 16, and so on. Total 18 iteration processes are there, out of which 16 processes are called the iteration process, and last 2 process is called post processing. So total 18 processes will be there. All the process will use a different key. So that is process 0 will use key number 0. 15 will use key number 15, and so on. The last pre-processing will use 2 keys, key number 16 and key number 17. Both will be used in the last pre-processing unit. Once the entire task is completed, the flag bit will go high, and we will know that the encryption or decryption task is completed, and the data would be ciphertext or the plain text will be available here. So we can take data plain text or ciphertext here. If I am a transmit module, then my plain text will come here and ciphertext will go out, and the receiver module, the reverse with the case. Then there is a clock given, there is a bit select given, which will select whether it will be processing encryption or decryption. And then the Blowfish algorithm generates this key using the SBox and P array. So the values are initialized in XBox and P array. Those values will be used to generate various 18 keys for Blowfish algorithm. The flow diagram, or you can say the iteration, would be like this. The data will come in the bunch of 64 bits. So my plain text will be in 64 bit. We will divide that 64 bit in the lower bit and upper bit. So this is a right, it's a lower bit, and L is the upper bit. The upper bit will be XOR with the initialized key. First key, it will be XORed, and that XOR will create F function. That F function will again be XORed with the right bit, and it will put in the left side, while this left side is directly put into the right side. This is how the iteration will work. All the 16 iteration will work the same way. Only thing is this key would be different for every different iteration. In the post processing, after 16 iteration, we have 64 bit out. That 64 bit will again be XORed with key number 16 and key number 17, and then the position will be interchanged, and then the final 64-bit ciphertext will come. So as per the previous slide, there will be 16 iteration, and as per this side, there will be post processing where 2 keys will be used simultaneously, and then we'll get 64-bit ciphertext. So this is the encryption process. The decryption process is exactly like this. The only thing is all the keys will be used in the reverse manner. So this is a symmetric key algorithm. So the same key will be used, but in the reverse order, and then we can generate the decryption from the given data. Now, if we talk in terms of RISC architecture, RISC-V architecture provide different kind of instruction set. The instruction formats could be R type, J type, B type, or I type. To have a simplicity in the design, we have used the R type or register type of instruction. The figure shows the format of register type of instruction. It's a 32-bit size of data, where 7-bit is the opcode. Then the opcode will design the operation that we are supposed to do, or you can say it's the code that will say that what exactly is to be done. So if we want to do encryption, we have to change this opcode for encryption and decryption. Otherwise, it will be a normal operational code of the RISC processor. This function bit 3 bits and this function 7-bit will combinedly decide what exact operation is to be done. It's a logical operation or arithmetic operation. If it's an arithmetic operation, then adder, subtractor, multiplier, whatever work we will need to do. The 5-bit destination register will give you the address where the result will be stored. And this 2 5-bit source register 1 and source register 2 will give you the address of the bits or address of the data which is to be processed. So R type instruction, this is one example, add T1 S0 S1. S0 and S1 is the place from where we will get the data. So instruction code for add is this 0094033333 and the binary number is this. If we decode this binary number, the last opcode is saying 0110011. That is an R type instruction. Function 3000, it is for addition. Destination register is 00110, that is 6. So location number 6, whatever is the result will be stored here. Source register 1 and 2 is location 8 and 9, from where we will get the data. Function 000 will tell us it's an arithmetic operation. So this is a normal R type instruction. We want to modify this instruction for our crypto processor. Now, how we have integrated? So this is our RISC-V, which has instruction fetch unit, register file unit, arithmetic and logic unit. It also have a clock and active low reset. The output of 32-bit is available and there is a flag. When the output is 0, the flag is set. Otherwise, the flag is always 0. Now, when we introduce the custom instruction, the same R-type instruction is used. Only thing we will modify the opcode. So you can see that, let's say ENC S9 S8 T4 that says use an encryption. This is hexadecimal code and this is the binary number for that. If you look at the opcode, all ones means we want to do cryptographic instruction. So when 111 is received as an instruction, then our processor will understand here we want to produce the encrypted or decrypted data. So it will give the control to the crypto processor. Otherwise, if this bit is not 111, then the normal RISC processor will work. Then EDB bit is 1, that is the output of our, you can say the encryption block, that is this block, the select bit here. That bit would be 1. It shows that we are producing encryption. If you want to produce decryption, this bit has to be 0. Source register is 29. That means from 29 register, you are getting the data to be encrypted. And there are 2 destination register where our data will be stored. Similarly, we can do the description where this particular bit will change and we will be performing the decryption. Other things will remain same. So AXI interconnect is a very powerful interconnect which is widely used between IP cores and system on chip. The same interconnect we are going to use between our crypto processor and our RISC processor. And we are going to use AXI Lite version. AXI Lite version requires less resources, so we are going to use it. It has 2 different kind of transaction, write transaction and read transaction. In the write transaction, what we'll do is our RISC module is a master module, while the crypto processor would be our slave module. So RISC module will first assert AXI write valid signal, make it high. Then the slave would pass on the ready signal when it receives the valid signal. When both the signals are 1-1, that means now we are ready to send the data. So on the next rising edge, we will send the data and the crypto processor is ready to process the data for encryption or decryption.
Excuse me, sir. I'm really
Yes.
sorry to interrupt you. However, we have crossed the 10-minute mark. I just request you to kindly conclude as soon as possible.
Yeah, I'll take only 1 or 2 more slides.
Okay.
Okay, similarly, we have write transaction where both the master and slave will produce the handshaking and then the write cycle will be produced. This is the final result that we have got. We have implemented this RISC processor on the Altera Cyclone 2 EP2C35 672C6 series of FPGA. And these are the various logic elements they have used. The total build time was 2 minutes and 11 seconds. We have compared this processor with various reported architectures, and it is observed that the time required for execution is minimum in our case, that is 160 nanosecond. The other counterparts are taking the minimum time of 8 microsecond, which is still very high compared to the design that we have proposed. So finally, we have successfully implemented 64-bit blow-fish cryptography algorithm on the RISC-V processor, and the design is modular. We have developed the custom instruction using AXI Lite interface, and successfully we have tested the design. These are few references that we have used. So that is all from my side.
Thank you so much for your presentation, sir. Ma'am, do we have any questions for sir? So ma'am has typed her question in the chat box if you can see it. Innovative topic, really useful to improve the performance of system. Nice presentation. Thank you so much for your presentation, sir. Okay, now moving ahead, I'd like to call upon our next presenter. Our next presenter is Kriti Karande, presenting a paper on the title Optimizing Shortest Path Selection in Weighted Graphs, a hybrid approach using BFS and machine learning models. I request you to kindly take over with your presentation, please. Ms. Kriti.
Hello everyone, this is Kirti. My presentation topic is optimizing shortest path selection in weighted graphs using the very hybrid approach, that is a BFS and some machine learning models algorithms. So this paper is under the guidance of Sujata Kadu ma'am and the Deven Shah from the Devna Engineering College, Mumbai, Derul. So as if, as we know, the shortest path is one of the foundational graph traversal technique where we can use the BFS algorithm, one of the traditional approach. Okay, so BFS has the systematic traversal algorithm which can explore the nodes layer by layer and starting from the source node to the destination. But in our project, we are there are lots of problem with the BFS having like a memory segmentation, the weighted graphs as well. So here we have implemented not only BFS but also we are integrating them with the machine learning approach. We have used two machine learning algorithms. That is the one RF, that is random forest algorithm, and one is gradient boosting algorithm. So with the help of BFS and machine learning approach, we can finding out the optimized shortest path along with the efficiency routes and different application areas too. So as sorry, so here they have some here it is have some literature review regarding with the same topic. There are lots of papers, but there are some few are segregated. One is the in the application waste management. Here we have only implementation of the BFS along with the CSV5. So in this paper, we can say this model graph of the transportation uses the BFS for the efficient route for the garbage collection terms. According to the sorry. So, towards the literature review, there is a latest research with the Zhu Yuan paper, that is the integration of machine learning in the pathfinding. Here, they have find some limitations on the BFS and handling that weighted graphs, and this BFS having the integration with the machine learning, having the best option to finding the traversal and the pathfinding system where machine learning algorithms can be used to prioritize the edges based on their weights and their relevant features. So in some cases, we are using supervised and unsupervised machine learning models that can be trained to predict the most efficient path on the historical database. So in our project, we are exactly performing and we have already implemented this methodology with the integration of the BFS, and here we made the comparison out of these two machine learning algorithm, which one is best. So here first we implemented BFS algorithm along with the CSV5. So we grab the data for the navigation system around we 2000 nodes to find out the best shortest path. So here we make the attributes like age, cost, time, user feedback to train the data. And then in this project, we generate the CSV file to represent the graph's age data. This file having the make a use of network X, that is the primary library used for the graph-based computation in the Python, which simplifies the creation, manipulation, and the study of the study of the structure of complex network. Also, we have uses some other libraries like Pandas, Scikit, Matplot, and NumPy with respect to the BFS traversal to find out the shortest path. Here with the implementation of the shortest path along with the BFS algorithm. Here it is the graph representation, and there are some few which of the thousand nodes we have created. Once the node of the each node of the graph is visited, that goes into the visited set, that is in the that array. Then it goes to the next node and finding out the distance between the nearest distance between the source and destination. That it is the approach very traditionally. So this is what exploration. This process is continuous until the queue is not empty. Once the queue is empty, BFS will stop. So in this process, we have find out some disadvantages, or I can say we are addressing the disadvantages of the BFS. Because as if BFS is widely used graph traversal algorithm, still there are issues like a high memory usage. BFS requires to store all the nodes and edges, and these limitations can lead to performance issues and memory constraints. Second, BFS assumes all the weights equally, disregarding varying travel times, cost, and user feedback. And of course, that may cause to the finding out the uh, shortest path. And of course, it is not handling the some real world constraint at the time. Hence, to overcome these disadvantages, we employed the strategies like machine learning algorithm. Here we incorporated the random forest regression model to predict the best path score. The model is learned assigned weights to each feature on importance, effectively addressing overall these limitations. Here we use the CSV, of course, CSV based storage, lazy loading file, and also machine learning algorithms. The machine learning algorithms included graph loading, the graph creations. Here there is a weight assignment attribute to load calculations. There is a formula related with the load calculations. The path exploration. Based on that, there is a output in terms of train and test splitting, which is in the ratio of 80 is to 20. Random forest regression model from the Python. Here we can reassemble machine learning algorithm that works combining multiple decision tree to make the predictions. Here, a detailed explanations of the random forest, where the random forest we can use to calculate some kind of a parameters, come metrics, error metrics, and at the same way, some gradient boost algorithm we have used implemented to calculate that metrics. The metrics like MSE, that is a mean squared error, it gives more weighter to larger errors because errors are to be squared. Then there is a RMSE, that is a root mean squared error. This error is the same unit as the largest targeted variables, making easier to interpret the result. MAE, mean absolute error, it gives an idea how much predictions deviate on average from the actual values without squaring the errors. Last two, that is the R square score and the variance score. R square score, this is used to indicate how well the predictions match the true data, and variance score, that is used to evaluate how much variance in the true values is explained by the actual predicted value. The both the value is, which is near to closer to 1, which indicates the better model fit. As we see in the table, RF, that is a random forest, and gradient boost both gives the value 1. It means we cannot say that the random forest is greatest and the gradient boost is better one. Actually, both are good for the finding out the shortest path. But there are some prioritized conclusion. If we prioritize the fastest training, robustness to the noise, and ease of integration, interpretation of the result, then must say random forest could be more suitable than the gradient boost. In the scenario where the predicators errors paramount, random forest may be absolutely a preferred choice. So to demonstrate, we have already demonstrated these two RF and gradient boost. So here we can make this such a conclusion. In our summary, we can say the combined use of BFS and machine learning for the pathfinding and age prioritization offers a comprehensive solution for the developing intelligent navigation system that can scale efficiently and adapt to changing conditions in the real time. Also, it can handles the graph files, CSV, and pandas very efficiently on the real-time system. The real-time traffic data integration with the API, it also manageable with respect to the machine learning algorithms. Also, it is a scalable for the smart cities navigation system, or it is a scalable with the any other extra parameters. Adaptive models are used to transfer the learning. There are some additional exploring reassemble method for stacking, bagging, and transfer learning techniques can improve the system adaptability to changing conditions. Finally, there is a user-friendly interface with the visualization tools can facilitate user interactions, decision making in the system, which is more accessible to the wider range of the user. That's all. Thank you.
Thank you so much for your presentation, ma'am. We have a question. How many or which features you use for route prioritization?
Okay. Feature in terms of attributes, ma'am.
Yes.
Okay. So basically, we have used 1,000 nodes in terms of this weighted along with the weighted graphs. The weights are in terms of time, cost. Uh, then there are weighted assignments, feedback from the user.
Okay. Do we have any other questions, ma'am? Okay. No. Thank you so much, ma'am, for your presentation.
Thank you.
Thank you. Now I'd like to call upon our next presenter for this session. Our next presenter is Deepak Iligade, presenting a paper on the title Satellite Image Analytics for Tree Enumeration for Diversion of Forest Land. I request you to kindly take over with your presentation, please.
Thank you, ma'am.
Thank you, sir.
Good afternoon to everyone. I'm going to share my screen. I'm audible.
Yes, sir, you're audible.
Is my screen visible?
Yes, sir, your screen is visible right now.
My name is Deepak Kanchigade. I am from JS College of Management, this institute. We are three authors. Deepak Kanchigade, that is myself, Suraj Jadhav, Abhishek Moyete, these are my partners. And we are build this project under the guidance of Dasar and Vasudha Kulkarni. And one more author is that is Rupali Patel. I'm missed to write a name here. Uh, there is the contents, introduction, contributions, objective, overview of the project, future scope, key achievements, challenges and solutions, workflow, conclusion, and snapshot. Introduction. Briefly, overview of the project. Just imagine that if we have to count a number of trees in particular area, how we can how uh, how can we count number of trees? That is very difficult to count the trees in the particular area. For that purpose, we made this software web application. This project focuses analysis of satellite images to count a map, trees, and forest areas that were that are proposed for diversion of an for non-forest activities. The project goal is to develop an automated system to detect and count the trees from satellite image or drone images. Important of this project, the project supports environmental conversation by providing accurate data to access forest land, diversion impacts, and policies decisions for the forest management, improve efficiency through automated tree counting, and ensure data-driven planning for effective afforestation and mitigation efforts. The contribution, the collection and preparation. The acquiring satellite images of the target area from reliable sources, uh, spelling to and lands. Uh, Preprocessing the data such as removing noise, adjusting resolution, and normalizing pixel values of the images. We are use algorithm like OpenCV, a random OpenCV, scikit-learn, TensorFlow, and two more models we are using, RVNN, RVNN, and YOLO 8, YOLO V8. Core of the project includes the website with a landing page dashboard offering the following tools like tree count, green cover estimator, optimal pathing, and historical data. Description of the project scope, development of an AI-powered system for automated tree enumeration using satellite imagery and deep learning models such as YOLO 8. Key deliverables, a functional prototype that an AI-based tree enumeration system using satellite imagery, integration with deep learning algorithms, a user-friendly dashboard that visualizes tree counts and deforestation pattern for stakeholder analysis. Significant milestone reached. Successfully developed and trained the YOLO V8 deep learning model for a real-time tree enumeration detection and enumeration. Complete comprehensive data collection, preprocessing, and enhancement of satellite imagery using NVIDIA and EVI indices. Challenges faced so far: managing missing or incorrect data during the preprocessing stages, uh, ensuring model accuracy with version algorithm. This is the basic architecture of our project. Firstly, we taken and take we can select any image like that can be taken by a drone or that could be a satellite. There are two models about recounting or location map and classification. In recounting, we recount the tree. That model recount and location mapping, and second model is classification and detection. And after that, we get a result. Here is the architecture. Uh, we dive in brief. Here is a snapshot of the project. Here the tree count, the green cover area, tree spaces, optimal pathing, and historical data. Here I select an image that is uh, taken by a satellite. I take this from Google and just on upload in our model. It gives a 53.38% green covered area and ideal land present is 46.62. And this is the basic UI of the our project. Real-time application, one of the real urban tree management, and second is forest monitor. The conclusion: the project showcases the use of the satellite imagery and based deep learning and automated tree counting and forest monitoring. It replaces manual survey with the scalable, accurate solution, offering timely insight into deforestation. here are the accuracy with the references. I taken references here in the list and the accuracy of the each author here. And our model accuracy is 90.1%. Thank you. Thank you for your time.
Thank you so much for your presentation, sir. We have a question from our session chair. How many data sets you used? What is the accuracy rate in your system? What is the criteria for classification of trees in the execution phase?
We use two data sets. There is a problem to get. There is a one of the problem to collect the data set. We are taken a roadmap as well as a train map data set. There could be a so much trees when we are traveling, and we are a small click to get that data set. It can be helpful to develop this model. And what is the accuracy in the rate our system is 90.1%. What is the classification? Yeah, in classification we use RNN model and RNN model, the real-time neural network, and one of the YOLO V8, the V8 that model that creates a mask of particular image, like a like a triangle. Like a triangle, it's created, and for that basis we count the trees, and as well as we get the percentage of how many percent of are covered by green area. Thank you, ma'am. Is there any question?
So we have one more. Okay, that says larger data sets with image clarity is highly essential for your research.
Yeah, yeah.
Okay. Thank you so much for your presentation.
Yeah.
Thank you so much, ma'am, for your guidance.
Yeah. Thank
Now
you.
I'd like
Thank
to
you, ma'am. Your
thank you.
time.
Now I would like to call upon our last presenter of our session. So Chanta Ravan presenting a paper on the title Secure Authentication Using Biometric and Behavioral Analysis. I request you to kindly take over with your presentation, please.
Hi, am I audible?
Yes, ma'am, you're audible.
Okay. Is my screen visible?
Yes, it is visible.
Okay. So thank you for giving me the opportunity. I am Suchanta Babasaheb Ravan presenting a research presentation on title Secure Authentication Using Biometric and Behavioral Analysis conducted under the guidance of Professor Prashant Dhotri from MIT Arts, Design and Technology University, Pune. Our research focuses on building a robust and secure authentication framework that goes beyond traditional password by combining biometric factor with behavior trains. So let's start. In today's digital era, secure authentication is critical to prevent sensitive data and secure privacy. Traditional password-based systems suffer from major limitations such as being easy to forget, vulnerability to suit phishing and credential reuse attack, and and offering no contextual or continuous verification. To address these weaknesses, there is a growing need for multi-factor and contextual aware authentication methods that goes beyond static credentials. Biometric and behavior authentication, such as fingerprint, face recognition, keystroke dynamics, and GPS-based validation, provides robust, user-friendly, and difficulty to spoof solution that enhance security while providing usability. These methods enable real-time and continuous authentication, making them suitable for modern application across finance, healthcare, government, and enterprising systems. The motivation behind adapting such system streams from increasing threats like phishing, mimicry, and mimicry, attack, along with challenges such as irrevocable biometric data, once leak, password leak, false positive, false negative, and traditional systems, token loss, hardware dependency, and the high cost of secure dependency. Hence the integration of biometric and behavior authentication has become essential to build reliable, scalable, and intelligent across control systems. This is the literature review, which gave me an idea about how biometric and behavior analyze works. Sadril was Sarvada were among the earliest researchers to highlight the vulnerabilities of static authentication system and stress the need for behavior based alternatives. But the other authors also emphasizes the lack of privacy presenting model and standardizing in biometric system, pointing out the risk of irrevocable data breaching and template threat. The challenges faced during these highlights were false positive and false negative. Beyond further, the existing systems which came after researching by the authors. The traditional authentication methods include password-based authentication, fingerprint authentication, voice recognition, signature-based system, and continue to face significant limitations in the face of evoking cybersecurity threat. Collectively, these studies also identified and indicated gaps across current authentication systems, including security vulnerability, poor scalability, inconsistent performance, lack of standardization, limited real-world testing, usability issue, resource constraints for AI development, and the absence of continuous authentication mechanism. This refined the need of a robust and user adaptive authentication approach that combines biometric and behavior analysis. The objective of the research was the primary objective of the research is to enhance authentication mechanism by integrating biometric and behavior data for improving security and usability. First, a comprehensive literature review will be conducted to understand the current landscapes of authentication systems, identifying gap and evolving and is already done and explained. Based on these sites, the goal is to design a robust authentication framework that incorporate both biometric and behavior models. This framework will be implemented into a working system that supports real-time and contextual aware authentication. The next step involves developing a secure authentication solution that effectively combines and process multimodal data using machine learning techniques. Finally, the proposed system will be evaluated and compared against existing methods based on performance metrics such as accuracy, recall, false positive, false negative, etc. Insider. The proposed secure authentication system was evaluated using various metrics to understand user behavior, system performance, and model accuracy. Based on insights from the authors, Analyzing of user authentication patterns reevaluated that the average successful login time was approximately through 3.2 seconds for face plus fingerprint, and 5.6 seconds for keystroke and face combination. Among the available two-factor options, face and keystroke emerges as the most preferred by users, accounting for 41% of total users. Login activity was predominantly observed during morning hours, where 54%, following by evening 32%, and night 14%. For GPS-based login analyze are disclosed as for 87% of login attempts organized from registration user location, while 13% were new unregistered location. A total of 8 alerts were triggered due to location mismatch, with the average GPS verification time of approximately 1.2 seconds. In the security incident summary, during an insight, the system recorded 186 login attempt with 34 failed login. 5 accounts were logged due to exceeded the maximum amount of login failed, and 12 alerts notification were sent via email or SMS. On average, log accounts were reliable within 5 minutes. This is the accuracy compared charts, as I have done research by using more of the literature survey. In terms of AI model performance, the Treasonfall based LSTM classifier uses the keystroke dynamics. Most the GPS based authentication is 78%, and multi-model fusion is on 99%. This is a single authentication system, and by combining both biometric and behavior analyze, the authentication techniques are at the high point of securing the data. This is the flow chart how the system will work. When we start the system, if the user is new, then it needs to register and then log in, and if it is already logged in, like registered, then the user login, then choice for biometric and behavior authentication. According to the choice, the authentication will be checked by the system. If the authentication is been checked and it is successful, then the successful login to the system and the process will be end. If not, then the login will be failed and again restored to the main login page. If this cross the limit of 3 or 8, then the system will send a message to the registered email ID or the mobile, and the system will be locked for 5 minutes and the end of the session.
Excuse me, ma'am. I just request you, this is just a reminder that we have crossed the 10-minute mark. So please conclude as soon as possible.
Yes. So authentication methods which can be included, which can be offered are in 4 distinct models, like face plus fingerprint, fingerprint plus keystroke, keystroke plus face plus password, GPS, which GPS is being checked overall during the registration and login. These are the choices given to the people user for combining which biometric or behavioral choices they want. In biometric authentication, the system for face detection, it uses OpenCV with LBP and CNN. For fingerprint match, neurotechnology finger SDK for accuracy, speed, a fallback mechanism. We use OpenCV for face recognition and Verify SDK for precise fingerprint match, both optimized for real time. This then in behavior models, keystroke dynamic pattern for typing pattern SDK like typing DNA and dwell time can be used. For mouse mode, then for mouse click and pattern edge is being calculated. GPS GPS then for GPS tracking, validate location during login and 8 attempts failed, the notification will be sent to a registered email and the system will be locked. This is the security features. 3 login attempts, after 3 login attempts failed, the system will be locked, email and message will be sent to the specific registered email. AES-256 RSA GPG PGP for encryption is being used. Security is not just about detection. We also implement alert encryption and blockchain based logged for forensic. Then for hardware setup, Raspberry Pi and USB composed devices, face fingerprint, keyboard, GPS are mounted on the hardware, or can be, or even laptop face cam and laptop keyboard can be even used. The Raspberry Pi integrates all peripheral and transmitted structured data through USB services, acting as a HID device. Then we can even set a Docker and Docker for fetching up the data, SQL for local storage, MongoDB for cloud storage, and Firebase for alert. We use Docker to simplify deployment. SQL let store a local records, while cloud services handles alerts and backups. These are the results which I have been implemented. First, the registration page, which will ask email, phone number, and two-factor option. Then according to the filling, it will be the second email. The figure 2 is the successful registration of the credentials of the user. Here is the login page. And this is the one demo of keystroke plus face, which I have taken by implementing by putting all the credentials. My system is been unlocked, and when I put the wrong credentials, it will send an email to my registered email ID, which is the figure 6. Now I would like to conclude. The proposed system presents a secure and reliable authentication frameworks by effectively combining biometric and behavior analysis, offering strong protection and traditional passwords than traditional passwords or OTP based methods. By seamlessly integrating multi-factor authentication, it enhances user security without compromising usability. Further, we can even integrate cloud IAM platform, blockchain based logs, mobile version, adaptive learning for behavior change AI among detection. We believe this hybrid authentication method offer further of secure access. Continuous learning and mobile support will make it even more stronger. These are the references which gave me motivation and how it basically works by these authors. Thank you. If
Thank you
any
so much,
question.
ma'am. How GPS will work for behavioral analysis? Is it worth to consider GPS for this? What is the difference between sentiment analysis and behavioral analysis?
Just a second, I'll open my chat and I'll give answers. Okay. For GPS, GPS will be working for overall. Like during registration, it will ask the user to location, and it will overall for every model it will work during the login. It will overall calculate your location. It will ask for your location, and it will match the registered or the before login location, and it will match. If it is not similar, then it will send you the message. And difference between sentiment analyze and behavior analyze is different, as sentiment analysis just understanding emotional or tones, like positive emotional, and behavior analyze is keystroke, mouse, and habits. Then in basically in sentimental analyze, marketing social media is being attacked, and here there can be there it can be attacked using fraud detection or authentication systems. Fraud can be made. Then it is. Thank you.
Okay. Thank you so much for your answers, ma'am. Thank you so much. With this, we come to the end of our session.
Okay.
You can stop sharing your screen.
Yeah.
Yes. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of this conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificate through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I would also like to thank our session chair, Dr. Archana, for chairing our session. There's a small token of appreciation from our end, ma'am, for you for chairing our session. I would just like to show it. Thank you so much to our chair on behalf of Team ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, ma'am. Now, I request all of you all to kindly switch on to your cameras for a quick snapshot of this virtual session we just attended. Thank you so much. Stay safe. Take care. We'll meet you in the next international event in 2025. Thank you.